Hello and welcome to another episode of Study Session. In this video, we'll be covering a topic in AP Chemistry called, and it's essentially over chemical reactions in periodicity. I butchered that name, the second word, periodicity, but it's essentially, periodic trends or whatnot. That's essentially the premise of it. So our first question is, this ion will generate gas bubbles upon the addition of hydrochloric acid. So our possible answers are Cu plus 2, so copper plus 2, CO3, 2 minus. I hate how the minus is like after and the plus is after. I always never did it, and I got through chemistry just fine. So we get Fe plus 3. I'm going to write plus 3. It's really 3 plus, and, or like if it's like some number n minus, plus or minus, but I'm lazy, so I don't do that. It's just a habit. Or Al plus 3. So we know that gases, bubbles are made. So that implies that there's a gas that's like forming. And if we look at these, metal, no gas, metal, no gas, metal, no gas. So our only possible answer is CO3. Disregard that, because it has oxygen, and I guess never mind. Carbon is, I didn't know if you guys knew this, but carbon's not a gas, but you have the oxygen, which is a gas. So that would be your answer. So it says aqueous solutions of this ion are blue, and this is mainly just a memorization thing. So the answer would be copper. So in this case, it was copper plus 2, and that's just memorization. And typically, the transition elements will be the ones with color. So like ions containing, or like compounds containing, like if we have like a periodic table, this is gonna be like a terrible drawing of the periodic table. And we have like the lanthanides and actinides, or however you pronounce that. I guess this actually extends further down there, and then it's like bada bing, helium up there. But like these compounds with these have color, or like ions, those are colored typically. So that's pretty much, you don't even really need to know that for the, I mean, I guess probably you need to know that they're colored, like, but you don't need to like memorize like what's colored and what's not for the AP Chemistry exam. Okay, so the next question says, which of the following are the balanced net ionic equation for the equation of lead 2, or for the reaction, of lead 2 carbonate with concentrated hydrochloric acid. So lead 2 carbonate, so that's Pb, which is lead, and then it's 2, and then carbonate, so CO3, is minus 2, so it's a 1-to-1 ratio. And then it wants to know the reaction with concentrated. It wants to it's net ionic. Okay, so if we were going to write this out or whatever, we would write it out as we have, and sorry, I forgot the last line. It says all lead compounds are insoluble, so it's net ionic reaction. So we're going to write the original reaction. And then that gives PbCl2 plus H2CO3. And if I were to quickly balance this, there we go. Okay, so it's net ionic equation. So we know that these will stay solid. So it's PbCO3 solid plus 2H plus AQ plus 2Cl plus AQ gives PbCl2 plus, and then this is solid, plus H2CO3. And then presumably this would be aqueous. Okay, and we know that, in this particular reaction, it produces carbon dioxide and water, so disregard all this. Disregard all that. So this would actually be, it turns into PbCl2, and in all these, they had the correct PbCl2 on the, so PbCl2, and then it showed you that it would turn into carbon dioxide and water for all of them. So you didn't have to know that, but apparently it does, and I should have checked. So if I just actually CO2 plus H2O. And it wants a net ionic reaction. So net ionic reaction is things that are chemically reacting. So we know that our carbonate is obviously changing because it's obviously reacting since it no longer exists. And then our lead is obviously still reacting, and our water, which is produced, is still reacting. So that would be simply our net ionic equation would be PbCO3 plus 2H plus Q 2Cl minus. Did I call it Cl plus? That's Cl minus. I don't know what I'm thinking. Gives PbCl2 plus CO2 plus H2O. Okay, so on to the next one. I'm pretty sure on the AP Chemistry exam, the only one I missed was a net ionic equation, which is really depressing because those are like the easiest things in all of AP Chem. And I was just a bit confused there because, like, I'm pretty sure net ionic equation, if it stays solid, I don't know. Net ionic equations are weird. They're kind of dumb, but regardless. Oh, what did I do? Okay, so the next question says, a sample of copper metal is reacted with concentrated nitric acid in the absence of air. After the reaction, which of the final products are present? So we have copper metal, so Cu plus, and it's HNO3 is nitric acid, so those react, and we form CuNO3, and copper is typically plus 2. So this would be NO32 plus H2, and then we would balance it like that. And it wants to know which of these final products are present. So if we look at our final products, first off, we have, if we were going to, going to write out this reaction, we know that we have our reacted copper, and this particular reaction actually does produce. So this particular reaction actually produces water. It doesn't produce, or it produces water, but it also produces nitrogen monoxide. So that would, essentially, this is the reaction. Based off the answer choices, you would have picked. There were 3 answer choices, and one of them had the correct formula for copper nitrate, copper 2 nitrate. So that's how you would pick this problem. You don't have to know that produces that, but the only answer choice for this particular problem, which makes it kind of hard while I'm trying to explain it, because it's like I don't know the reaction for that. But the only possible answer choice would be the one with only, formula for copper nitrate. Okay, so the next problem says potassium metal will react with water to release gas in a form of potassium compound. Which of the following is true? So we have K, so our potassium metal plus HOH gives. And we know it's producing it's producing a gas, so presumably that gas will be hydrogen, and then we end up with KOH. So if we remember and I'm not going to bother balancing this because you don't have to know it for this particular question. So if we remember our solubility rules, potassium, and for that matter, all alkali metals are soluble in water. So this is going to dissociate into K plus and then OH minus. If you remember OH minus, that makes solutions basic. So our possible choices are the final solution is basic. The gas is oxygen, which we know that's not true because it is hydrogen. Potassium compound precipitates, not participates, precipitates, which is not true because potassium is soluble in water. And it says the potassium compound will react with strong bases. That's just completely wrong. Potassium forms the strong base. So the final solution is basic is your correct answer for that one. And we see that's true because it produces potassium hydroxide, which will dissociate into potassium and the hydroxide ions, which will form a basic solution. Okay, so this next one, I'm just trying to find a good problem to do. Okay, so I found our next problem. It says how many moles of PbNO3 NO3. And this is 2. So how many moles of that must be added to 0.1 liters of 1 molar MgCl2, so MgCl2, and 1 molar KCl to participate all the chloride ions. And it says the compound PbCl2 precipitates. So to solve this problem, we know that if we were going to write both of our net ionic equations, we've got, or not net, just our reactions. We got PbNO3 2 plus MgCl2 gives PbCl2 plus MgNO3. So we essentially need 1 mole of lead for every 2 moles of chlorine, and essentially 1 mole of that for every 1 mole of that. Okay, and then we have PbNO3 2 plus KCl gives PbCl2 plus KNO3, and this would be 2. This would be 2. Okay, so to solve this, we know that we have 1 liter of 1 molar MgCl2 and 1 mole of KCl to participate the chlorine ions. So we know that in our we have 0.1 moles of this just by basic stoichiometry, because molarity is moles per liter. If we multiply across, we got 0.1 molar. So we know that we need 0.1 molar there. And this, so we have, if we do some quick stoichiometry, so it's 1 molar. So 1 mole for every, or, if we're going to start off with 0.1 liter, and if we have 1 mole per 1 liter, so 1 mole of KCl2. Okay, and then for every 1 mole KCl2, we have 1 mole PbNO3 2. So that gives us 0.5 mole. And then you simply add them together, and we get 0.15 moles of PbNO3 2. Okay, so hopefully you guys enjoyed this video. Be sure, if you guys have any questions or any suggestions, be sure to leave them in the comments below, and I will be making more videos very soon. I just get a bit busy sometimes with school, but whenever I have free time, I love to make these videos and kind of share my it's sometimes hard to remember, but I need to make sure that I stay sharp on my chemistry skills. But hopefully you guys enjoyed, and make sure to watch any of the videos that you find helpful. Let me know if they are helpful. And also, I will be creating sometime within the next 2 weeks. I'm working on a website, the official study session website, and on there will be a forum section where you guys can post comments, post questions, and I will do my best to answer them. So if you have any other questions, once this forum comes up, or once this website comes, I'm done with it, then I will be gladly answering questions if I have the knowledge to. And if I don't have the knowledge to, I will do my best to find somebody who does have the knowledge to be able to answer them. So hopefully you guys enjoyed. Be sure to look out for whenever I create my website, and that is the end of this video.